Alright, so I've posted before. I recently added updates to this Hello Z80 World code. So I'm running it right now. So as you can see, it's spitting out onto the screen this hello and welcome to my shell. Which, granted, it's not really a shell in the strictest sense because it's not processing anything. But that's beside the point. I'm kind of looking to make this into something more like a call and response type shell. I don't know how complicated doing this will be, but it should be pretty fun to try to get working. So I can now type hello world, hit enter, and as you can see, so I also have this cursor key, so I can move it around, so up, down, left, right, and then if I go to the edge of the screen, it wraps around, although it does go up one row. Then, as you can see, I can actually move the cursor over text, and then I can backspace over text as well. So I can go to this period in shell dot. I can backspace over that. Okay, and like if I hit enter, it doesn't overwrite this hello part. Anyways, and then I can just type all sorts of things. Yeah. And the reason why this works, in large part, is because I added some processing within this emulator. I had to add in a little bit of stuff to this emulator. One of the things I added today that was I did some calculations of how to actually properly split out the opcode lengths, so that I can more properly say, if I'm executing an instruction, here is this block of code that is specifically the instruction. It's not the data part that's part of the instruction when it's like a wide instruction. But that's besides the point. So I'm doing this SDL poll event. So in addition to having an event that lets you quit, there's this text event input, which takes and puts to this variable, this global variable char input, and then it forms an interrupt. So it sets halted to equal to false, Z80 interrupt to this, and then while halt is equal to false, it runs until it goes back to a halted state. All right, and then this, and then in here I have this interrupt service routine. So it disables the interrupt. It swaps out the registers. Then it does a key input location, so this key input location it will draw from this variable, this char input variable. It will take that char input variable and put it into A, and then it will take and it will push, and then it will put A into a key buffer, which is just an arbitrary location in RAM, in the RAM spot. So I've decided here, so in the memory mapping, the interrupt, RAM starts at E000, and so the key buffer is at E001. And so it stores that into the key buffer, and then it resets the key input location to 0. It swaps out the registers, then it returns, and then that causes it to return to this main loop. It causes it to return to this main process input, wherein it will read that key buffer, and then this is essentially a glorified switch statement, and that it will check to see if it's a new line character, in which case it will print a new line character. This checks to see if it's an up, down, left, or right, or a backspace, and then if it's none of those, it will take and will put the character into this standard out address, and then it will call this store cursor value. Alright, and then main print new line will invoke the call for print new line, and then up does some calculations with the grid iterator, as well as a cursor value. Down, left, and right do the same thing basically. Then backspace does a similar thing, although it's more just putting a space at that location in the grid iteration. It's complicated, but that's because I probably could optimize that better, but that's beside the point. Yeah, so, and storing cursor value will take the current display variable, and it will store it. Yeah. Now, this is in addition to all of the other stuff that is being done here. And one of the big ones is that so this is tile set end, tile set origin, and so it starts at the space. And that file is included here, tile set defs, and then in and then I can do this call. I can load into HL a message, and then I can call print HL, and this and one of these messages will get printed. It's sort of like a printf, although it doesn't have any sort of, it's not like it's not powerful enough to do any sort of substitution or anything like that. It just verbatim prints out these characters to the screen. So like this is space, this is exclamation point, this is the pound, then dollar, percent, so forth. There are some that I don't quite have a good way to print characters arbitrarily, but that's just because at the moment this thing only does the one thing. It only just lets you type, and currently I don't have a good way to type anything that's not that is a part of any extended character set. I can only like type what's on this board, on the keyboard. Although I could try to do something where like if I'm holding down a certain sequence, then I can type other characters. Yeah, so, and that's what it looks like right now. I know on certain things like the Commodore 64, that you could basically use your cursor in this sort of way to in the C64 you could do a command called like poke, where you could say 3 2 1 5 2 1, and you could set that to be 0, and then it would set that value in memory to 0, and then you could cursor back up and then set that to 3, and then you could hit enter, and it would do the same thing. Oh, there. So I don't have anything to do that, although doing that would actually be mean I just have to make modification to the code in the assembly. I wouldn't have to make any modification to the emulator currently. But yeah, and fair reminder, this is a Z80 assembly. So Z80 is it's a derivative of the Intel I think 8080 assembly code, although the opcodes are, I believe they're almost equivalent. It's just that the wording that is used to refer to different commands had to be changed to avoid lawsuit from Intel. I think it was Intel, that's why which is why it's LD instead of MOV, which is what it is in other types of assembly. Yeah. So there's my code, and at the moment it's 2009 bytes. So not all that many bytes quite yet. So like a kilo or two. Which, granted, that I guess the PET didn't allow for a ton of bytes, but that's neither here nor there. So yeah, fun. Thanks for watching.